Welcome to this video. This is Stoichiometry video 2. This is about formula. This video is going to be about Ionic formula only. The syllabus says we have to find what the formula is of something. Number one, by looking at models or diagrams and looking at the relative numbers of the ions in those diagrams. And the second way is by the charge on the ion. So I've got some examples here of the first one. What are the formula of these compounds? And these are the diagrams. Well, the first one, as you can see, it looks like 1-to-1 there, doesn't it? There's sodium ions and there's iodide ions, and it's 1-to-1. Okay, if we count 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, it's 1-to-1. So 1-to-1 there, so its sodium iodide is simply NaI. Okay, and these are all going to be empirical formula, if you remember, because they're all going to have they're going to express a ratio, the simplest ratio. Potassium iodide, well, that's also potassium ions to iodide ions. It's going to be 1-to-1, so potassium iodide is going to, let's do it in a different color, it's going to be Ki, 1-to-1. Sodium iodide, potassium iodide. Let's check. Potassium ions, 1, 2, 3, 4, 5, 6, 7, 8. Iodide ions, 1, 2, 3, 4, 5, 6, 7, 8. So it's 1-to-1, so it's Ki. Next one is a tiny bit more complicated, all right, but it's potassium is the positive ion, and the negative ion in this case are nitrate ions. Okay, so if we look there, you can see there's actually 4 potassium ions to, sorry, there's 5, aren't there? There's 5 potassium ions to 4 nitrate ions. Now that's only because of the way the diagram is written. If you could expand the diagram, but it would end up as 1-to-1. So this is actually, I know it looks like 5-to-4, but it's actually a 1-to-1 ratio. And the formula of potassium nitrate is going to be KNO3. Okay, it's 1-to-1. Now this next one is a trickier one. Again, this is sodium ions to sulfide ions. What's the ratio here? Well, 1, 2, 3, 4, 5, 6, 7, 8 to 1, 2, 3, 4, 8-to-4. So that's going to end up as 2-to-1, isn't it? This is the empirical ratio, the simplest ratio, and 2-to-1 means the formula of sodium sulfide is going to be Na2S. Okay, so there's the formula: NaI 1-to-1, Ki 1-to-1, KNO3 1-to-1, and Na2S 2-to-1. Okay, so that's how you would do it diagrammatically. Look at the ratio and find the empirical ratio, the simplest ratio. How do you do it from the charges on the ions? Oops, I've got other things at the bottom there, haven't I? So we'll keep that down there. How do you do it on the charges on the ions? Right, now the way we do this is we look at the group number. Group 1, 2, 3, 4, 5, 6, 7, and group 8 or group 0. Okay, so if you're in group 1, you have 1 electron in your outer shell. That means you're going to lose 1, so your ions are going to have a charge of +1. If you're in group 2, you have 2 electrons in the outer shell, and you're going to lose 2 electrons, so you're going to be +2. If you have 3 electrons in your outer shell in group 3, you're going to lose 3, so you're going to be +3. +4, sorry, in group 4, you have 4 electrons in the outer shell. You're not going to lose 4 or gain 4, so these don't form ions. Group 4s don't form ions. If you're in group 5, well, you're going to gain 3, so your charge is going to be -3. If you're in group 6, you're going to gain 2, so the charge is going to be -2. If you're in group 7, you're going to gain 1, so it's -1. And if you're in group 8, well, you're not going to gain or lose because you're a noble gas. Okay? So these are the charges here. These are the charges on the ions. Okay, and let's pick a typical few, shall we? Right, let's say potassium, let's pick sodium, it's going to be Na+. Potassium is going to be K+. Group 2s, magnesium is going to be Mg2+. Calcium is going to be Ca2+. Aluminium is in group 3, that's going to be Al3+. No ions here. Group 5, nitrogen is going to be N3-. Phosphorus is going to be N3- as well. Group 6, oxygen is going to be O2-. Sulfur is going to be S2-. Group 7, you're going to get fluorine, F-, chlorine, Cl-, bromine, Br-. Okay, so there we go. All right, these are the charges on the ions. Let me move this up a bit and get rid of this from a previous video. I thought I'd got rid of this, but obviously I haven't. So let's get rid of some of this. Or some of it doesn't go because it's circles. Okay, but I don't think we need much room here. Sorry about this. This looks a bit messy, doesn't it now? And my computer's very slow today. It's an internet thing, I think. All right, no, this isn't good, is it? It's taking forever. Sorry about this. And I've nearly used my 6 minutes, so I don't want to be much longer. All right, you'll probably hear the alarm go in 19 seconds or so. Right, there we are. So let's have a look at, well, you have to have a positive ion in an ionic compound, and it's going to be with a negative ion. Okay, but together, if you add up all the charges here, it must be neutral in a compound. There's the alarm, that's 6 minutes gone. So it's going to be neutral in the compound. So let's pick one from this side. Let's pick sodium. Okay, and let's pick one from this side, oxygen, O2 minus. Now, how will I make this neutral? Well, if I have 1 to 1, it won't be neutral, will it? Because there'll be 1 times 2 minus and 1 times 1 plus. Doesn't give me something that's nice and neutral. So if I have sodium and oxygen ions here, or sodium ion and oxide ion, for every 1 oxide ion, I'll actually need 2 sodium ions. Okay, so 2 times plus 1 is going to be the same, or exactly the opposite, I should say, as 1 times minus 2, because that will give us the neutral thing. So the formula for sodium oxide is going to be Na2O. Okay, let's do another one. Magnesium, 2 plus, chloride. All right, so for every 1 of these ions, I'll need 2 of these ions to make it neutral, and therefore the formula will be MgCl2. That's magnesium chloride. Let's pick one over here. Let's pick a different one, shall we? Aluminium, 3 plus, sulfide. That's 2 minus. Now this one's a bit more complicated, but if you figure it out, if you have 2 of these, it has a charge of plus 6. So we need a charge of minus 6. So we need 3 of those. So the formula for aluminium sulfide is going to be Al2S3, because that will give us a neutral compound. Okay, one last one. What should I pick? Calcium oxide. Okay, now if I have 1 of these, well, it's going to match up with 1 of these, isn't it? So it's going to be 1 to 1 here. I need 1 calcium ion for every 1 oxide ion. So the formula for calcium oxide is CaO. Okay, and that is how we find out ionic formula using the charges, and how we find out ionic formula given models or diagrams. Okay, thanks.